and share my screen and open the chat in case somebody wants to type something. Although hopefully you know that I would like to really encourage you, if you have a question, to ask it. Oh dear. And I think I'm going to have to send out an email because there's some important information here. Today is September 29th. We're going to be looking more at equations. We're also hopefully going to get to the point of looking at functions. Two homeworks, 12 and 13, are due by the end of the day today. 3 homeworks will be due by a week from today. But I want to give you a heads up. This is not for any of your other classes, but my classes will not be meeting Thursday. So we will not have class on Thursday. I am the campus representative to an organization, the Faculty Council of Community Colleges, that meets every semester. Usually we meet in person on a different community college campus every semester, and there's usually 2 people there from each community college in the state. And we talk about state issues and bring information back from like the state to our campuses. And we're meeting virtually this semester, but the meeting's on Thursday and Friday. So I will not have classes on Thursday or Friday, and I'll also have no office hours on Thursday or Friday.
Is it this Thursday coming up or next Thursday?
Thursday the 1st.
Okay.
And I will send an email reminder that we will not be having class on that date. If you need to get a hold of me, send me an email. It's sometimes rude, but I guess if we're meeting in Zoom and not in person, I can check my email periodically during the meeting, but I won't, probably won't answer you back until the end of the day. So that having been said, everybody's made note of the fact.
I don't know about that.
Before we pick up from where we left off last time, those homeworks that are due today, or any of the preceding homeworks, does anybody have questions on any of them? Does anybody want to look at anything that we've done thus far in this unit, new unit on graph 9 or words? If you're not talking, could everybody please mute? But I'm asking you to mute, and then I'm asking you to talk to me. I'm sorry, that's a little hypocritical, but you guys know what I mean. Does anybody want to?
Someone usually want this. I'm sorry, did you take attendance already, Professor?
Yes, I did. I was going to take a guess at the end of class. Now, those of you who came in late, tell me who you are and I'll add you.
Lynn.
I saw you come in, Lynn. I'm sorry.
Oh, good, thank you.
Who else came in? Somebody else came in.
I came in late. Kate.
Kate, thank you. Kate, what's your last name?
Kelly.
Thank you. I got you. All right. So today we're going to pick up then from where we left off, which was working with the idea of slope. And so just a real quick review of where we were. And I had this open to the page we left off at. Here we are. We had said that in order to graph a line, we could make a table of values. We said we could use intercepts. We said for the y-intercept, we're going to let x equal 0 and get a point 0, 0, pardon me, b. For the x-intercept, we are going to let y equal 0 and get a point a, 0. And those would be our points on our axes. Then the next thing that we did was we talked about the idea of slope, and we said it's a measure of slant. We said if we have 2 points, x1, y1, and x2, y2, the slope is the change in the y values, the difference in the y values, over the difference in the x values. And I, tongue-in-cheek, said the way I remember that the x's are in the denominators because everybody likes to bury their x's. We're putting them in the bottom. And we said that if the slope is positive, we have a line that goes uphill, increases. We said that if the slope is negative, we have a line that goes downhill, decreases. And between positive and negative, we talk about if the slope equals 0, and if the slope equals 0, I have a horizontal line. And then we said that if there is no slope meaning that the slope is undefined, which comes from having a 0 in the denominator, we would have a vertical line. And if I remember correctly, that was where we left off. That's a very, very, very quick review of what we did last class. Does anybody have questions on any of that? If not, let's take a second to do a little bit of practice. I'm going to throw up here a couple pairs of points, and I want you to find the slope of a line through the given points and describe the line. And by describe the line, I want to know, is it increasing, going uphill? Is it decreasing? Is it horizontal? Or is it vertical? And so I'm going to give you a few pairs of points and ask you to do those. Let's look at the points 1, 3, and 3, 9. Let's look at the point 2, 6, and 9, 6. Let's look at the points 1, 7, and 1, 5. And let's look at the points 2, 7, and 4, -2. And I'm going to shut up for a minute and ask you folks to please find those slopes between those points and tell me what you get. James, I got that you came in. Demond, I got that.
Okay, thank you.
know when you folks are ready to go over them. Are we ready yet, or do you need for me to wait a couple more minutes? Help, talk to me, people. Are we ready, or do you want me to wait?
I just finished.
Can we just take another minute for everybody? Are we ready?
I'm ready.
Okay. First, look at the difference in size. Nine minus three. The axis is 2 minus 1. So when I work that one, I get answer 3.
You're cutting out a little bit too, sorry.
Does that sound better?
Yep.
Yep. That 3 is positive. Since it's positive, the line is increasing. This next one, when I subtract the y's, I get 6 minus 6. When I subtract the x's, I get 9 minus 2, and that gives me 0. And again, if the slope is 0, the line is horizontal. This third one, when I subtract the y's, I get 5 minus 7. When I subtract the x's, I get 1 minus 1, which gives me a 0 in the denominator. So we're going to say that's undefined. And when you have no slope, it's a vertical line. And then the last one, when I subtract the y's, I have -2 minus 7. When I subtract the x's, I have 4 minus 2, gives me -9 over 2. And since it's negative, I know that my line is decreasing. How'd you all do? You have like with all those decisions?
I didn't get all the equations done, but I did get the right direction.
That was me.
Did you get the right slopes?
Yes,
Yes, the right slope.
I
Okay.
just didn't get it all done in time.
Oh, hello. You should have told me to wait. I'm so sorry.
But I understand the concept.
Okay. Just yell at me if I go too fast. You know what? In a classroom, it's easier to wait because I can walk around and look over shoulders. But when I'm just sitting here, I don't know how to judge time, so I'm very sorry. And so we're all right with finding the slope if we've got 2 points. We're going to also have to be able to find the slope of a line if we're given the equation. And this is one place where I differ a little bit from the author. I would put this a little bit later in the chapter, but she throws it in with the slope homework And so because it's early in the homework, I'm going to just throw it out at you at a rule, and we'll look at the y of it in probably about a half an hour. And so let's say I have an example. Let's say I want you to find the slope of the line with the equation and my equation here is going to be 6x plus 3y equals 6. And if you wanted to, you could pick 2 points, pick 2 numbers for x or pick 2 numbers for y, and find the other coordinate and use the slope formula. But there's an easier way. If I have a linear equation and I want to find its slope, the first thing that I have to do is solve for y in terms of x. And this is one of the last things we did before the test when we were looking at solving equations. And so here, where it says solve for y in terms of x, that's a fancy pants way of saying I want to get y alone using my rules of equality, and x will be on the other side of the equation. So, looking at the equation, I'm going to rewrite it. 6x plus 3y equals 6. Does everybody remember? Before I can get the variable of y all alone, I want to get that y term alone. And so to get the y term alone on one side of the equal sign, I have to move the 6x. And can anybody remember what I do to each side of the equation to move that 6x? Since this is positive, I'll subtract it. And on the left, it works nicely. 6x minus 6x is 0. That leaves me with 3y. And now on the right, does everybody remember those are not like terms? I can't combine them. So that's going to leave me with negative 6x plus 6. If you really wanted to, you could write that as 6 minus 6x, but it's most normal to put the variable part first. Now now y is almost alone. In order to get the y all alone, we'd have to move the 3. And because they're being multiplied, does everybody remember, we'll divide both sides by 3. 3 divided by 3 will be 1. And now does everybody remember, when I have more than one term in the numerator and one term in the denominator, in my mind I have to think that I'm dividing both of those terms by the 3. And so negative 6 divided by 3 would give me negative 2x. 6 divided by 3 would give me plus 2. We did a lot there. Is everybody comfortable with where this version of the equation came from?
Yes.
Please. If we're all right, what turns out to be really, really, really cool, once we get the y alone, once we're solved for y, the slope turns out to be the x coefficient. And so over here, I would be able to say that the slope is -2. And if we've got that linear equation, that first degree equation in two variables, the equation with x and y, without exponents written on them, just having that exponent of 1. If we're solved for y, the slope of the line will always be the x coefficient. So let's look at a couple more of these. Let's find the slope of the line with the equation. And can I scroll this up a little bit and not lose anybody?
Yes.
Yep.
And so my equation this time is 5x minus 2y equals 8. And again, in order to do this, we've got to solve for y. So I'm going to have an equation y equals, and I want you folks to let me know what y equals in terms of x. I'm going to be quiet for a couple minutes, and this time you folks really tell me if you're done, and we'll look at it. Are we there yet, folks, or no? Should I wait?
I just got the -2y equals 3x and then divide by -2 and -2.
Be careful, because the like that you subtracted the 5x both sides. That's great. And like that you got the -2y. But over here, are the 8 and the 5x like 2?
I can't hear you, hon.
Can you hear me now?
Yes.
Okay. As I look at that, are the 8 and the -5x like terms? One has an x and one doesn't. So I can't combine those. So I have to leave that as -5x plus 8.
Okay, gotcha. Yep.
But then I also like the next thing you said, that we're going to divide both sides by -2. That's awesome. But you have to remember over here on the right-hand side, we're dividing both the negative 5x times negative 2 and the positive 8 times negative 2. Negative divided by negative is positive, and I'm going to leave that as the fraction 5/2. Positive divided by negative is negative, and 8 divided by 2 is 4. And so what we get here is y equals positive 5/2 x minus 4. And so now that I've got that done, I'm just looking what number is being multiplied by the x, and that tells me that my slope is 5/2. Is that good, or shall we try one more?
Can we do one more?
So this time, let me ask you to find the slope of the line with the equation. And this time, let's say we've got 4y minus 3x equals 16. And so could everybody please solve that equation for y and tell me what the slope is?
I'm ready to ask you a question whenever you're ready.
Okay. What question would you like to ask?
If I got to the answer,
Uh-huh.
I'll wait.
Is everybody else ready?
Yes.
Yes? Okay, I'm thinking this final answer should be y equals 3/4x plus 4. And the slope should be 3/4.
Correct.
Should I add the details, or are we all happy campers?
I got it.
You got it?
Yeah.
Everybody, if you didn't get it, speak now or forever hold your peace. Okay. Then if we know how to find the slope by looking at an equation, we can start talking about cool things like if lines are parallel. Oh, you know what? I'm changing the way I write that. Parallel. And has anybody heard of the word parallel before?
Yes.
What's it mean? Can you remember? I think most people think of parallel lines as lines that never cross. If I have this line and this line, we'd say they never cross. So we'll say that parallel lines are lines that have no points in common. Then I'm going to add something a little bit different. No points in common, or all points in common. And so what do I mean by that? All points in common. Up here, if I could draw those two lines that I drew with the arrowheads on them, if I could draw straight lines, in theory, they could go off in each direction infinitely and never cross. For all points in common, what we're going to say is if I draw one line, we'll say that that line can be considered parallel to itself. And so if we add that possibility of a line being parallel to itself, a line is parallel to itself, and I want to shut up for a minute and backtrack. Sometimes, because there's a couple of P words with lines that we need to know. Sometimes when I think of that word parallel, does everybody see all the L's in the word parallel? And you see how all of those L's, especially these middle two, look like parallel lines. And so all of the L's in the word parallel give me a visual reminder that what those parallel lines look like. So now if we add that a line can be parallel to itself, when I look at parallel lines, I'm going to draw these ones going in a different way. Yeah, I can't draw. Sorry about that, folks. Are you all right if I say that parallel lines go in the same direction, have the same direction? They have the same direction. They have the same slant. These two here are slanting downward in the same way. The L's are all vertical. They're going in the same direction. These two are both increasing. They're going in the same direction. So parallel lines have the same direction. They have the same slant. And didn't we say that the slope is just a measure of the slant? So we'll say that two lines are parallel. If they have equal slopes. And so if a question asks, are two lines parallel? In order to determine if lines are parallel, well, if they're parallel, they go in the same direction. They have the same slope. What we have to do is we have to find the slope of each. So, do you folks need me to wait a minute for you to catch up? Or are we ready for an example?
Ready?
Okay. Example, I'm going to ask, are the given lines parallel? My first line is going to be y equals 2x minus 6. And my second line is going to be 4x minus 2y equals 10. And so we said what we need to do in order to see if they're parallel or not, sorry, I tripped on my tongue, is to find the slopes of each of them. To find the slopes of each of them, we want to get y alone. And so is everybody all right? Here, y is alone already. My x coefficient is 2. So this line has a slope of 2. Excuse me. Now in the second line, y is not alone already, so we have to solve for y. In order to do that, I'll subtract the 4x from both sides, giving me minus 2y equals, and again, hopefully everybody recognizes that the 10 and the negative 4x are not like, so I'll leave that as negative 4x plus 10. Then I'm going to divide both sides by negative 2. Here, negative 2 divided by negative 2 is 1y, which is what I want. On the other side, remember we have to divide both terms by the negative 2. Negative 4 divided by negative 2 is positive 2x. And positive 10 divided by negative 2 is negative 5. And you see how this one also has a slope of 2. And so since they have the same slope, the lines are parallel. So the lines are parallel if the slopes are the same. The slopes are equal. So parallel lines have equal slopes. Now that we know how to find the slope of a line, we can tell if lines are parallel by just seeing if those slopes are equal. With me so far? Same work as last time, we're just comparing the numbers for two different lines. And if parallel lines, are all right, the next place we're looking are perpendicular lines. And the symbol for perpendicular kind of looks like an upside down T. And that symbol for perpendicular, that upside down T, reminds me that lines are perpendicular if they intersect at right angles. And does everybody remember a right angle is a 90-degree angle? Sometimes you show perpendicular lines by putting a little box in that corner. Is this definition vaguely familiar?
Yep.
So to tell if lines are perpendicular, we're going to have two things we need to remember. To tell if lines are perpendicular, first way is we're going to always say that a horizontal line remember a horizontal line has a slope equal to 0. And if I have a horizontal line, the equation will be y equals a constant, is always perpendicular to a vertical line. And a vertical line, again, has no slope. We say that the slope is undefined, which is a fancy pants way of saying when I did my workout, I got a 0 in the denominator. And its equation is of the form x is equal to some number. And does it make sense that if I have a horizontal line and a vertical line, that they would indeed intersect at right angles? And so if I look at an example here, I'd be able to say that the line y equals 2 is perpendicular to the line, let's say x equals -3. And beyond just stating it, I'd like to take a minute to make sure everybody remembers how to graph those lines. The line equals 2, y equals 2, pardon me. Is everybody all right? I'm going to go to 2 on my y-axis. And then for y values to always be 2, I'm going to put a horizontal line through 2 on the y-axis. The fact that it's y equals 2 tells me I'm starting at 2 on my y-axis. And then for the other line, x equals -3. I want to go to -3 on the x-axis, and I'll draw that vertical line through there. So that's the line x equals -3. And you see that if I were on graph paper, those would indeed intersect at the corner of the grid. So a line with 0 slope is perpendicular to a line with no slope. So far, so good. A horizontal line is perpendicular to a vertical line. If I have two lines that are not horizontal and vertical, I'm going to ask you to be a little patient with my drawing. Let me make a pretty steep line. That looks kind of steep, doesn't it? And what would you tell me about that line's slope? If it's going uphill, it would be positive. And now if I try to draw a right angle here, you see how one line has a positive slope, one line has a negative slope. And as one line gets steeper, doesn't the other one get flatter? So they have opposite signs. One's positive and one's negative. And they behave in opposite ways. As one gets steeper, the other gets less steep. And to say that they behave in opposite ways, it turns out that that will tell us that the slopes are reciprocals. So putting the pieces together, we'll say that perpendicular lines have slopes that are negative reciprocals. So what do I mean by negative reciprocals? Slope a lot of time comes out to be a fraction. So I'll have something like the fraction a over b. And when I take its reciprocal, remember we said that means we're going to flip it, b over a. So those are reciprocals, and to say that they're negative reciprocals means that one is positive and the other is negative. So in order for lines to be perpendicular, the slopes can be negative reciprocals. Or one is vertical and one is horizontal. We need that other definition, vertical and horizontal, for the other lines. Because if I look at my horizontal line, the horizontal line has a slope equaling 0. And the vertical line, if I look to find the negative reciprocal, the negative reciprocal of 0 over 1 would be negative 1 over 0, but I can't write that. It doesn't exist. And so that's why we need to spell out the horizontal and vertical lines. So in all practices, how do we find if lines are perpendicular? We have two choices. They can be horizontal and vertical, or we're going to find the slopes and see if they're if they're negative reciprocals. Am I getting too lazy abbreviating negative reciprocals, or is that all right?
That'll be fine for me.
So let's look at a couple of problems here. First problem, let's find the slope of a line that's perpendicular to the line. And let me say I've got y equals 3x plus 6. To find the slope of a perpendicular line, I need to find the slope of this line. And because y is alone already, I can just look at it and see that this slope is 3. And when I talk about perpendiculars, I want to think of that as being a fraction. So I'll say it's 3 over 1. So the perpendicular slope I want to take the reciprocal, so I'm going to turn that upside down, 1 over 3, and then change the sign, make it negative, negative 1/3. With me so far?
I'm hanging on.
Okay, so then next question, I'm going to ask, are the given lines perpendicular? And let me say I've got y equals negative 3/4 x plus 2. And my other line is going to be 3y minus 2x equals 0. And again, for both those P words, parallel and perpendicular, I focus on finding the slope. And so in this first line, does everybody see that y is alone? So we can just look at it and get the slope from the x coefficient. This line has a slope of negative 3/4. The other line, I've got to do a little bit more work because the y is not alone. It's not solved for y. So I have to solve for y. In order to do that, does everybody see I'd add the 2x to both sides, giving me 3y equals 2x. And then to get y all alone, to solve for y, we'd have to divide by 3. And I'd get y equals 2/3 x. And so this one has a slope of 2/3. So one has a slope of -3/4, the other has a slope of 2/3. I'm going to compare them. They do have different signs, but are they reciprocals? If I turn 3/4 upside down, do I get 2/3?
No.
No. So since they're not negative reciprocals, they're not perpendicular. And the question didn't ask it, but would we all also be in agreement that they're not parallel either because the slopes are different? In this homework, the homework on parallel and perpendicular, you'll also see one other type of question. Can I turn the page, or do you guys need me to slow down? You okay?
Yep.
So next example, I'm going to say given 2 points, and my points are going to be 5, 7, and 3, 6. I want to know 3 things. What's the slope of a line through the points? Sorry, I can't spell. Actually, I'm abbreviating. Then I want to know what's the slope of a parallel line. And I want to know what's the slope of a perpendicular line. And right now, we have, well, I guess technically we have 3 ways of finding slope. We could plot the points, draw a picture, and count blocks, rise over run. Or if we have 2 points, we have to use that slope formula, y2 minus y1 over x2 minus x1. Or if we're given an equation, we can look at the x coefficient when we're solved for y. Here we've got 2 points, so I'm going to use that slope formula. My y values are 6 and 7, 6 minus 7. And then the corresponding x values are 3 and 5. And again, I think we discussed that the 3, 6 has to be 1 point, the 5, 7 has to be the other point. The coordinates have to line up. So that gives me -1 over -2. And negative divided by negative is positive. So we have a slope of 1/2. If that line has a slope of 1/2, what do we know about slopes in order for lines to be parallel? Anybody? Parallel lines go in the same direction, so what has to be true about their slopes?
Has to be the same.
They have to be the same. So if that line has a slope of a half, what would the slope of a parallel line be? A half. And then for a perpendicular line, we have to shake things up quite a bit. We have to turn that number upside down, 2/1, and change the sign. Since it was positive a half, we get -2/1, or we can just write that as the number -2. Parallel and perpendicular, all right. Parallel equal slopes. That makes sense because they got the same slant. They go in the same direction. Perpendicular, the slopes are negative reciprocals. They do opposite things. One goes up, one goes down. One's steep, one's not. And so that helps me remember that their slopes are opposite reciprocals. Change the sign and flip it. If that's all right, then the next section asks us to do something like find the equation of a given line. And if I wanted everybody to draw the same line on a piece of graph paper, and I was trying to describe that line to you, wouldn't you need to have at least one point that's on the line so that everybody's putting their line in the same place? And then wouldn't it suffice to know the slope of the line, the slant of the line? And if everybody started at the same point and had the same slant, the lines would be the same. So to find the equation of a line, we need a point on the line, and we also need the slope of the line. And when we need the point in a slope, we use something that's called the point slope formula. And so to find the equation of a line, through a given point, we'll say that we have a point, and we're going to just arbitrarily say its coordinates are x1, y1, with a given slope. So we'll say that the slope is some number m. We use, and now here's the big bad formula. So far, with graphing, there's one formula that you need to know. It's that slope formula. The slope is the y2 minus y1 over x2 minus x1. This is the second formula that you're going to need to know. The point slope formula says that y minus y1 is equal to m times in parentheses x minus x1. And so this is called the point slope form. And you need to know that formula. Can I, in like a little bit of scrap area off to the side, show you what helped me remember that formula, helped me to learn that formula. This formula is really not very different than my slope formula. My slope formula is m equals y2 minus y1 over x2 minus x1. When I look at that slope formula, I know 2 points. When I look for the equation of a line, I only know 1 point. So the first thing I'm going to do is I'm going to not use the subscript 2's. So that gives me m equals y minus y1 over x minus x1. And now I want you folks to think about what we did very early on in the semester. If I think of this m as being m over 1, do you see how it's a proportion? And so with that proportion, if I cross multiply, when I cross multiply, I get 1 times y minus y1, which would just give me y minus y1. It's equal to m times x minus x1. And so I know there's a lot of people who tell me they have a hard time remembering that formula. And I guess I want to say that that formula is not very different from the slope formula. All you have to do with your slope formula is cross multiply to get it. So a memory aid if you want. But you have to be able to use it. So let's, for example, find the slope. I'm sorry, not find the slope. I apologize. Let's find the equation of a line. With a slope of, does anybody have a favorite number that they want to use for a slope?
3.
3, okay. And let's have it go through the point. So I need 2 numbers. Does anybody else have a favorite number? Pardon?
6.
6, and I need 1 more number. I guess I'll make it up. I'm going to make it -4. And so when I look for the equation of a line, do you see how we have a point and we have a slope? And so that makes me think that I'm going to use my point slope formula. And the point slope formula, again, is that y minus y1 equals m times x minus x1. M is the slope. So here we say that m is 3. x1, y1 is the point. So my point is 6, -4. And so x1 will be 6 and y1 will be -4. Up to that point, is everybody all right? And my screen just got dim, so I want to plug the computer back in. I have to start unplugging it because last night when it was plugged in all the time, it overheated and stopped on me. That's no fun. So now I'm going to just substitute what I know. Y minus y1 is -4 is equal to m m is my slope, 3, times x minus x1 is 6. And when you look at these questions in my labs, they're going to ask you to do this a couple of ways. This is the first way. This is my line in point slope form. I guess if you wanted to clean it up just a little bit, most people don't like that double negatives. So we could say y plus 4 is equal to 3 times x minus 6. And if they ask for the line in point slope form, they want you to stop there. Next, you might see them ask for it in slope intercept form. And we're going to see in a couple minutes that slope intercept form means that we have to solve for y. And so if I were to take that equation, y plus 4 equals 3 times parentheses x minus 6, to solve for y, to get y alone, does everybody remember the first thing we do is simplify what's on either side? So distributing will give me y plus 4 equals 3x minus 18. And then to get y all alone, we'll subtract the 4 from both sides, giving me y equals 3x minus 22. And so this version, where y is all alone, is called my slope-intercept form. And then there's one other form that they sometimes ask for, and that's general form. And in a general form, x and y are on the same side of the equal sign. And so over here, with y equals 3x minus 22, I want to move the x so that it's on the same side as the y. So I'll subtract 3x from both sides. And that'll give me negative 3x plus y equals negative 22. And this would be my general form. What do you think? Should we try a couple?
Sure.
So, first example, let's find the equation of the line with slope, let's say 1/2, through the point, let's say 10, 4. And again, we have a point and we have a slope. First, we're going to want to find it in point slope form. And to find it in point slope form, we've got to remember that point slope equation, y minus y1 equals m times x minus x1. What number would you folks tell me to use for m this time?
1/2.
Yep, beautiful. X1 would be 10. Y1 would be 4. The X and Y values of my points. The plain old Y, when we have an equation of a line, we need those letters in there, those variables in there. So I'm going to leave that Y alone. Y minus the Y value, 4, is equal to M, the slope, 1/2 times, and that plain old X, again, that's going to be the other variable in our equation. So we're going to leave that alone. And we substitute in for the subscript at 1, 10. And so that's in point slope form. For slope intercept form, we want to solve for Y. So I'm going to take that equation, Y minus 4 equals 1/2 X minus 10. Don't lose your parentheses. And first we have to simplify the left. We'll do that by distributing. And I've got Y minus 4 equals, let's see, 1/2 times X is 1/2 X minus 1/2 times 10. Well, half of 10 is 5. Now Y is almost alone, but not quite. We'll have to add 4 to both sides. And remember, when you do that, to make sure you line up your like terms. And I get Y equals 1/2 X minus 1. And then for general form, we want to move the X over with the Y. So where I have Y equals 1/2 X minus 1, I'm going to subtract that 1/2 X from both sides. And because they're not like terms, I won't combine them. Negative 1/2 X plus Y equals negative 1. That should be acceptable, but most people like to make it look a little bit nicer. And to make it look a little bit nicer, we can also multiply both sides by the denominator of my fraction. So where I have negative 1/2 X plus Y equals negative 1. To make that look nicer, to clear the fractions, we're going to say, okay, the only denominator I see there is 2. So I'm going to multiply both sides by 2. Distributing on the left, 2 positive times negative is negative. 2 times 1/2 is 1. 2 times Y is 2Y. 2 times negative 1 is negative 2. And so this is also general form. Of those two, which do you think looks nicer? The one with the fraction or the one without?
I guess the one without.
One without. And so be able to realize that if you have a fraction in there, you can clean it up by multiplying both sides by that denominator. I think that this fractional answer is acceptable, but this one usually looks a little bit prettier. And in terms of looking at our lines, I said we were going to have three methods of graphing. To graph a line, we said we could make a table. And that's what you did in that second homework from this chapter. We could use the intercepts. Which we did by making a very specific table, one substituting 0 for x and one substituting 0 for y. But the third method that we're going to look at now, which is most people's preferred method because it's a lot less work, and that's to use the slope intercept form. And so we said for the slope intercept form, we have to solve for y. And that gives me something of the form y equals mx plus b. We said that m, the x coefficient, will be the slope. And the slope tells me how to move. And then over here, that b turns out to be the y-intercept. And it tells me where to begin. And we're always going to begin on the y-axis. Quick explanation of why. We had said that we already talked about the slope being the coefficient on the x. If I put in 0 for x to get the y-intercept, we just get that b. So to graph a line using the slope-intercept form, we're going to first solve for y. We're going to begin at b on the y-axis. And we're going to move from that point using the slope m. And usually we like m better if it's a fraction. And so that slope m, we had said, was rise over run. And I'm guessing some of you've seen this before, and this sounds very familiar. But I'm also guessing that for some of you, this might be total gibberish. So let's look at a whole bunch of examples. I'm going to sketch y equals 1/2 x plus 4 using the slope intercept method. Most of the work is done for us already because we're already have y, our equation solved for y. Since it's solved for y, I'm going to compare it to y equals mx plus b. Doing that comparison, does everybody see, my computer just slipped, that b is equal to 4? And so I'm going to begin on the y-axis at 4. So I'm going to draw my axes. And so 1, 2, 3, 4, that's where I begin. Is that part easy enough for you?
Yep.
And then M is the X coefficient. M is 1/2. Now, if M is positive, I'm going to think of that as positive 1/2. Positive means up 1. And then does everybody see, I can think of that as 1/2 as being up 1 over 2, because it's 1 over 2. So from this point, I'm going to use my blocks. I'm going to go up 1 and then over 2. Up 1 block, over 2 blocks. Is that straightforward enough? Rise over run. 1/2 is 1 over 2. It's positive, so it's up 1 over 2. And there's my line. Was that easier than making a table of values? I think so.
Yep.
So now let's look at another example. Can I turn the page?
Yep.
So this time let's sketch negative 3x plus y equals negative 2. Actually, you know what? I'm going to change my mind. Let's not make that a negative 3x. Let's make that a positive 3x. 3x plus y equals negative 2. This time, y is not alone, so we have to solve for y. To get the y alone, we'd have to subtract the 3x from both sides. Giving me y equals, and remember, those are not like terms, and we like to put the one with the variable first, negative 3x minus 2. Now that y is alone, we want to compare it to y equals mx plus b. Which point I'm going to draw my axes. Ew, I drew that in the wrong place, I'm sorry. Move that up a little bit. So everybody right, I'm moving that up a little bit because alphabetical order, I'm going to start with the B. B is negative 2. And so I'm starting at negative 2 on the y line. M is negative 3. And this is one point in time in life where you'd prefer a fraction. So I'm going to write that as negative. I'm going to write it underneath because I'm running out of room. So I'm going to write that as negative 3 over 1. Is everybody all right to change an integer into a fraction? We just need to put it over 1. And since it's negative, I'm going to say that's down 3, and it's over 1. So from my beginning point, I'm going to go down, because it's negative, 1, 2, 3, and over 1. Down 3 over 1. And there's my line. That one all right. If so, for the next one, let's look at 2y minus 3x equals 0. And again, we're going to try to get the y alone. In order to do that, does everybody see the need to add 3x to both sides? So I get 2y equals 3x. Then to get the y all alone, to completely solve for y, we have to divide by 2. And I get y equals 3/2 x. So my equation is y equals 3/2 x. And I want to compare it to y equals mx plus b. With me so far?
Yep.
Okay, if that's all right, alphabetical order, we're going to start with the b. What's b? What is being added to the x term? Is there anything being added? I don't see anything. And if nothing's being added, we'll say that b is 0. And so I'm going to begin at 0 on the y-axis. M is the x coefficient, 3/2. That's 3/2, so I'm going to go over 2. And that 3 is positive. Since it's positive, I'll go up 3. And so from this point, I'm going up 3/2. And there's my second point. And there's my line. Can we do this?
Yep.
Yes.
I want to do 2 more because they're kind of special cases. Next example, let's sketch y equals, I don't know, let's say y equals 7. I'm solved for y already. Y equals mx plus b. I need b. I need m. And again, there's 2 ways of doing this, depending on whether you see the glass as half empty or half full. Because there's a y there, I'm going to use that y equals mx plus b method. So let's look at that 7. Is that 7m or is that 7b? Well, is the 7 attached to the x?
7B.
7 is b. So I'm going to begin at 7. And m is not there, so m is 0. And so I'm going to have a horizontal line. So remember, if there's just one letter, if that one variable is y, it's going to be a horizontal line. Instead, if I have something like x equals -4, and I want to sketch that, Because there is no y, I can't use slope-intercept. So what we have to remember is that if there's just an x value, it will be a vertical line. Remember, we looked at these a little bit earlier. We said we're going to go to -4 on the x-axis because we're being told x is -4. And we'll draw that vertical line through -4 on the x-axis. And all of a sudden, it's a lot easier to graph a line if we can just look at the equation, find m and b, and we no longer need to make a table. There are some other types of questions that you'll see on this homework. And so other examples of problems you'll see on, I believe this is homework number, give me a minute, I'm looking it up. This would be homework number 15. It might be something like find the equation of a line through the points and I'm going to be given 2 points, 1, 7, and 3, 11. So in order to find the equation, all we have is that point slope method. And we have 2 points. You can use either point. It doesn't matter, whichever one makes you happier. But they gave me 2 points, they didn't give me the slope. What am I going to do?
Plot the points on the axis.
We could plot the points. That would work. I like that. That's an interesting idea. But I'm thinking, can't we find the slope using the slope formula? And so my slope,
Intercept form?
say that again?
Is that the slope intercept form?
No, just the slope formula.
Okay.
If we've got 2 points, we're going to use just the slope formula to find the slope. So the difference in the y's would be 11 minus 7. The difference in the x's would be 3 minus 1. And remember, whatever point gives me y1 gives me x1. Whatever point gives me y2 gives me x2. And so that gives me 4 over 2, which is 2. So my slope is 2. And now you can pick either point. And usually you only have to do this once. But I want to show you why you only have to do this once, so I'm going to do it twice. If I use the point 1, 7 the first time, and I'm going to use the point 3, 11 the second time. Point slope formula, y minus the y value is equal to the slope times x minus the x value. So y minus this first point has a y value of 7 is equal to my slope 2 times x minus this point has an x value of 1. I clean that up, I get y minus 2 equals, let's see, if I distribute, that would be 2x minus 2. If I add the 7 to both sides, I get y equals 2x plus 5. Very interesting. Instead, if I did the same work with the other point, I'd have y minus the y value is 11 is equal to my slope 2 times x minus the x value is 3. And right now, don't those two look very different? But if we clean that up, if we distribute, we get y minus 11 equals distributing 2x minus 6. And if we solve for y, if I add 11 to both sides, do you notice that I end up with the exact same equation? So with these problems, when you're asked to find the equation of a line through 2 points, use the points to find the slope. And then it doesn't matter which point you use in your point slope formula. I have 2 more examples that I'd like to make sure we get through today. And then because we didn't get quite as far as I had hoped, I'm going to make a very slight change into the homework assignments that are due on Tuesday. But first, let's look at these 2 examples. Next example, I want to find the equation of a horizontal line through the point 13, -7. And I guess for this one, we can, if you want to, use the point slope. But you have to remember that if it's horizontal, the slope is 0. Horizontal's got that z in it to remind me that the whole slope is 0. And when I go y minus the y value is equal to the slope times x minus the x value, I get y minus -7, which is y plus 7, is equal to 0 times x minus 13. But I'm not going to stress on that right-hand side because anything times 0 is just 0. And so when I solve for y, I get y equals -7. So I can use the point slope formula, or I can remember that horizontal is y is equal to the y value of the point. And so if I could remember that horizontal lines just have a y and no x, I could have just said, okay, all right, it's going to be y equals that number. And so instead, if I want to find the equation of a vertical line through a point, and let me say my point is, oh, I don't know, let's say 8, -2. Here, if it's a vertical line, you have to remember a vertical line has undefined slope, so we can't use the slope formula. And so it's always going to be x equals some number. And if I have a point, it's always going to be x equals the x value of that point. And so those horizontal and vertical lines, if you can remember, horizontal line is just y equals a number. It would be y equals the y value of your point. And for a vertical line, you have to remember that it's x equals, and it's x equals the x value of your point. And I've got on my watch that we have about 3 minutes left class time. Sadly, I wanted to do a little bit more than what we've gotten through, but we haven't gotten there. And so I'm going to go back to the first page. I also want to go back to the first page to tell some important information to people who got here late. And so this homework number 16, I'm chucking. Homework number 16 will not be due on Tuesday the 6th, but also please remember, those of you who were not here at the beginning of class, please make note of the fact that Thursday I will not be here for class, so we are not meeting on Thursday. I will mail you the new Zoom code Monday night for next Tuesday. So I'm going to stop sharing, going to stop recording.